In our case, this is the data set which we'll be using it, okay, to train the model. So here, first we use the shape thing here, HDF data frame name dot shape. This is the one will give you the number of rows and number of columns. How many columns are, if you see here, 5 columns are there. Number of rows are 148. Now the question is why only 5 records are displayed here? Because here I have used the 5, head of 5. That's the reason it gives me only 5. Next one is in the Seaborn package, there is a function called pair plot. And in this, I'm going to use the data frame. So what is our data frame name? HDF. And here x equal to var. So what are the variables which we need to plot it in the x-axis and y-axis price? Okay, in the y-axis, yes, obviously we need to plot only one variable. And kind equal to reg, which means a regression plot. And what is the size of this one aspect? Okay, so if you plot this one, you can see something like this. Okay, here the size and price, and if you see here the UDS and price. So 1 second. Into a height. Okay. So you can ignore this warning. You are asking about this, right, Deepa? So you can see the warnings, you can ignore it. In case of error, you will not be able to proceed further. So if I say ignore it, that doesn't mean, simply don't see it. See here, what is the size parameter has been renamed to height. Please update your code. Okay. Here, the size parameter is renamed to height. Okay, 1 second. Why it shows height here? It is not talking. 1 second. Let me just check the data set. Housing data.csv. And if I open it here, you can see size is there. And why the size? Yeah, size is displayed here, but here it is not displaying it correctly. Okay, we can ignore it. So what is the idea of using pair plot? Using pair plot, we can plot more than one independent variable in the exercise. Look here, size, UDS, and park, and MISC. And the Y variable, Y-axis, we use the price. Okay, so what does it shows here? Can someone tell me what does it shows here? UDS, undivided share. So here the UDS is something like undivided share. See here we are going to predict the price. So this is the target variable or the output variable. The rest of the variables are input variable. Size is here what you see here is size is in terms of a square feet. Everything is in square, in terms of square feet. We are seeing it here. Undivided share and park and MISC. These are the 4 columns, right? So all the 4 columns, we can see that the values are in square feet. You just think that way, okay? So 37.8 undivided share and parking lot and MISC. MISC is something like amenities, other amenities, like let's say you have swimming pool and gymnasium, all the things, okay? You have it. So these are things, okay? So now what we need to do is we need to train our model with these independent variables, okay? And this is our dependent variable, okay? So here, as I told you, in the case of linear regression model, each variable each independent variable or the feature has to be correlated with your target variable. In this case, the target variable or the dependent variable is price. Okay, the size should be correlated with price and UDS should be correlated. So whichever feature that correlates well with the price, those features we can use it to train our model. Okay. Look here, in this case, unfortunately, size is not, there is some problem here. And if you see your UDS and price, as the undivided share size increases, the price also increases. Similarly, the park, lot, and the MISC. But you can see the line. You need to go by the line. And if you see the line, most of the values just above the line are somewhat close by this, right? And whereas here, if you see park, most of the values are far from this line. Okay, and similarly here also. So with that itself, we can make out quickly the park variable and feature and MISC feature. These 2 features are not correlated well with our price. Okay, it is not. So this one and this one is not correlated well with this one. Hence, we can drop these two variables because it's not going to help. It's not going to help us to predict the housing price. But this one seems to be, good, somewhat good. But here, unfortunately, is not showing anything. Okay, there is some other problem. Okay, with the code. I just checked it one more time. So here, what it says, the size parameter has been renamed to. I think something it gets confused with the size. Okay, it is thinking that it is in a height or something like that. I don't know. There is no variable called height. It will not display because in our data set we have only size, isn't it? I just copy paste this. There is some confusion happening here. Okay, it is not coming up here. Let's leave it. We have another visual using which we can find out how well each independent variable is correlated with your dependent variable. This is very important. Yes. Here, I'm going to use something called the matplot library. I should have used it earlier. Okay, matplot lib.pyplot as PLT. Okay, Deepa has a question. So do I need to remember all these packages? Yes, there are some, see, not all the packages. There are certain packages, obviously you need to remember it. Okay, as a data science or machine learning engineer, you should remember this one. Okay, and here I'm going to use fixed size equal to 12,5 and then H core. I'm going to use something called heat map and htf.core function, and I'm going to use another parameter called annotation equal to true, so that the correlated values will also get displayed along with the values. Okay, so I'm going to hit the run button. See, what is this? Okay, plot PLT. Sorry, this is PLT. PLT.show. What is PLT? The matplotlib library. Now you understood why we are using alias, right? Otherwise, you'll need to type this big library name in front of your function name. And in this case, just you need to type the alias PLT dot figure. So here the height and width of this. And the 12 is an height of the chart and width is 5. And next one is hdf.core function. The core function gives me the correlation between each variable. For example, size and price, what is the correlation? UDS and price, what is the correlation? Park and MISC, what is the correlation with my target variable or dependable price? So each and every independent variable, how well it correlated with my target variable. That is what we are saying. So here, yeah. So if you see here, the 0.8 and 0.56, any value which is closer to 1, that means it is the correlation is very well. Okay, the relationship is very well. So I'll just write here the correlation. In statistics, we use a notation called OR. Okay, the correlation is OR, and it ranges between -1 and +1. Any value which is closer to 1, that means the correlation is very well. For example, size and price, the correlation value is 0.8, somewhat close to +1, which means the size independent variable or the feature, which is very much helpful in terms of predicting the housing price. Similarly, UDS is also right, somewhat, but though it is not so closer to 1, it is somewhat better than other values. Okay. So since the correlation value 0.56 for UDS and price, you can include the UDS feature in your model to train your linear regression model, right? But the rest of the features are not much helpful because it's all very weak. Okay, fine. Now we understood. So the park variable and MISC are not correlated. Probably we can drop those columns from my data set. Okay. How can I drop? We can, so instead of dropping it, what I'm going to do is I'm going to use the list here. Okay, list of values, features. I'm going to say here, I'm going to say size UDS. Anyhow, I'm going to include everything. We will see what is the impact. Let's not literally go by this correlation related matrix. Let's include all the features, the size, UDS, park, and MISC, all the features in a variable called features or in the list. Okay, and I'm going to say x equal to HDF. This is my data frame features. So in the features, I'm creating a sorry, 1 second. I just put it here correctly. Yeah, so you know how to create a list, right? So you can define a list in a square bracket. Here I have created a list. In this list, all the features that I mentioned, not the target variable price. Okay. So, and then what I do is this features, I'm going to pass it as an argument to my data frame HDF. So in that case, size, UDS, park, MISC, only that value will get stored in your X. And we need to have Y variable, that is your dependent variable. And here I'm going to say price. Got it? So you must be wondering why we need to have XY variable, so that when you train your model, you can tell very clearly, hey, these are the columns are related to dependent variables, or sorry, independent variables. This column is related to, or this variable is related to dependent variable. So here, instead of specifying each and every column, we can use X comma Y. X is holding all the independent variables or the features. Y is holding only the dependent variable. Okay. Now we will just check how the values are stored in X and Y. So I'm going to say print of X. That's all, guys. Okay. So now a size, UDS, park, MISC only displayed, not the price. Okay. Price is not there. So with this list, by passing the list as an argument to our original data frame HDF, we are able to get only these features related data and these features related data. Okay. Next one is the price. The price is nothing but your dependent variable. Okay. So in this case, what I am going to do is I'm going to see, now it is very important point. Okay. You need to remember it here. In the case of machine learning, supervised machine learning, what you need to do is you need to split your data set HDF. In our case, the data set is HDF. Split this into train and test data set. Okay. Usually the training data set will have more number of data in it, and test data will have less number of data in it. Okay. So in this case, I'm going to use something called sklearn dot model underscore selection import train test split. X underscore train and X underscore test, Y underscore train and Y underscore test is equivalent to train test split. So here I'm going to say X comma Y. The X is holding all the independent variable. Y is holding your dependent variable. Okay, random state is equivalent to 100. And the next one is, yeah, that's all. Now let us check how many records are there in X train and how many number of records are there in X test. All right.